Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
What's up? Welcome to Chemistry Connections. My name is Adithya Shrikanth and I'm your host for episode 1 called The Chemistry of Gasoline. And today I will be discussing the chemistry of gasoline. So gasoline is, as we all know, is a liquid you put into your cars. We've all seen gas pumps ever since we've been little, and we always wonder what's the difference between regular and premium, which is always an option we see at gas stations, but normally our parents go for regular because, well, it's cheaper. Gas prices these days are unreasonable. So today, and we always wonder what's the difference between car fuel and jet fuel, and why can't car fuel be used in jets and vice versa. Though I'll be talking about the chemistry behind gasoline, how it works, and the differences between every type. So the chemical composition of gasoline is C8H18. So that's 8 carbon atoms for every 18 hydrogen atoms. And it appears as a yellowish liquid. So you can imagine every time you go up to a gas pump and you're putting gas in your car, you can imagine something peeing into your car. The problem is that gasoline is a liquid, and for an engine of any vehicle to work, it needs fuel. The wondrous thing about gasoline is that it vaporizes at low temperatures. So the engine does not have to heat up much for the gasoline to turn on and become fuel. Now, problem being that fuel is a gas and gasoline is a liquid. So, but an engine needs fuel to run. So how does a liquid become a gas? Gasoline is a petroleum-based compound. So when the engine is running, the gasoline reacts with the air and a combustion reaction occurs, turning the gasoline into a gas. To understand gasoline further, we must know how the gasoline reacts with the engine, which every car has. Despite the types of an engine, and there are many, almost all of them use pistons. When the gasoline combusts, and that's the process in when a compound heats up, the explosion pushes the pistons down, which transfers energy to the crankshaft, which is another component of the engine. And after a couple more processes, this leads to a running car. So basically, the combustion reaction causes the pistons to push down, and the energy of that explosion causes the car to run. At the gas station, we see 2 options, premium and regular. And normally we use regular gasoline because, as I said earlier, it's cheaper. But why do these options exist? Why do we have 2 options? Why not just one? Well, the main difference between regular and premium is the octane level. Now, every single type of gasoline has this. Premium gasoline has a higher octane level. And what that means is the level of octane in gasoline indicates the likelihood of improper engine combustion, which in layman's terms is known as engine knock. The higher octane concentration in premium gasoline causes a lower likelihood of engine knock happening. This is why high premium gasoline used in high performance cars like Ferraris, Lamborghinis, they're all world renowned, and people are not going to want those type of cars to experience engine knock, so just bring for the premium option. So that reduces the likelihood of engine knock. So now we know the difference between regular and premium gasoline. But what about the difference of the gasoline that goes in jets and cars? Well, both have engines and both use fuel. And both aviation fuel and regular fuel use hydrocarbons, but the difference is the type of hydrocarbons each fuel uses. The hydrocarbons that make up normal gasoline contain 7 to 11 carbon atoms attached to hydrogen atoms. The ones that make up aviation fuel contain 12 to 15 carbon atoms. So jet fuel is made up of mostly kerosene. In theory, jet fuel can be used in cars, and it has been in the past, but it cannot go the other way. So car fuel cannot be used in jets. No, and this is because the conditions at which a jet travels are vastly different compared to a car. When we're on ground level, temperatures are normal. I mean, they're sometimes warm, sometimes cold, but it's not to the point where the state of matter of the gasoline changes. Problem being, and we've learned this in probably elementary school, the higher up you go in Earth's atmosphere, the colder it gets. And the conditions in which a jet travels, the temperatures can reach as low as negative 40 Celsius. So if we were to use car fuel in a jet, the gasoline would freeze. And what's going to happen? The gasoline freezes, it cannot be combusted, the jet's going to crash, and nobody wants that. So scientists have developed jet fuel. And since jet fuel is mostly kerosene, as I said earlier, it has a very low freezing point, which is lower than negative 40 Celsius. So this prevents the gasoline from freezing. So that is why jet fuel and car fuel are different. Well, we all drive cars, and we've been in cars as long as we can remember. From when we were toddlers, we see our parents driving, and until now, when we teenagers are driving. And one of the cornerstones of driving a car is gasoline. I mean, we all hate pulling up to a gas station. I mean, especially in Costco, where the line is probably the worst thing you can experience. And we always wonder what the difference between premium and regular fuel is, and the difference between jet and car fuel. But I hope this podcast really helped you understand the differences, and I hope you all learned something valuable. Thank you. Thank you for listening to this episode of Chemistry Connections. For more student-run podcasts and digital content, make sure you can visit www.hvspn.com. Have a good one.